When you hear about medical research in the news, it often says that a study showed that a treatment had a significant benefit, or there was a significant increase in risk, from which it would seem reasonable to take the message that whatever it was made a real difference. But that word, significant, is tricky because it has different meanings, one in everyday usage and another one completely in statistics. If I say to you, losing weight will make a significant difference to your health, you'd be justified in taking that to mean a worthwhile difference, one that is worth the effort. Numerically, how much would be worthwhile to you? A 10% reduction in your risk of things like heart disease? Probably not. 18%, which is what you'll get from statins at best, getting better. 33%, sure, that's worthwhile, that's significant. But in statistics, significant means something different. It only means that it passes the probability test we use to analyze results. Now, these are fairly complicated mathematical calculations, but that's not necessarily a problem. The main issue I and others have with statistical significance is that it's used as an all-or-nothing black and white statement, and people easily, sometimes deliberately, confuse or conflate statistical significance with real-life significance. It's like when you have a blood test for anemia, say, and the results come back with what's called a reference range, which just means a normal or acceptable range. Say we think you might be anemic, so we test your hemoglobin. The lab report says the reference range is 13.0 to 17.0. If your result is 12.9, just outside the range, the lab will flag that up as abnormal, i.e. you're anemic. But if it's 13.1, then according to the lab, you're fine, nothing wrong with you. Does that make any sense? No. And any sensible doctor knows that and will take it into account. After all, the difference between 12.9 and 13.1 is just 1.5%. And it could be down to whether you had one mug of tea at breakfast or two. In statistics, results are usually reported with either a probability or a confidence interval. Both work mainly on a 95% rule. If the mathematical probability that the result is right is over 95%, it's called significant. If it's less than 95%, it ain't. It's all or nothing. If the probability is calculated at 96%, you've got a valid treatment, a valid effect. If it's 94%, it's nowhere. That's just not sensible. Here's one example. A meta-analysis in 2004 by Miller and others with the title High Dosage Vitamin E Supplementation May Increase All-Cause Mortality. Now, there's a lot of other problems with this study, such as big differences in the age of the subjects and their health, in their diagnosis, in the dose of vitamin E, and in how long they took it for. And I think this is the paper that invented the trick of excluding trials without enough deaths in them, less than 10 in this case, which has proved very helpful in getting the results you want. But focus on the stats. Using the 95% rule, they just scraped in with a 96.5% probability for the conclusion that high-dose vitamin E, over 400 units per day, increased mortality from all causes. But how much did it increase the risk of dying? By 39 persons in 10,000. That's less than 0.5%, or 1 in 256. How significant is that? To be fair to the authors, the title does say may increase mortality, but that didn't stop lots of media trumpeting the result as a significant increase in risk of death and probably persuading a lot of people to avoid vitamin E. Just because it passed the statistical test of significance doesn't mean it's got real life significance.